Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. It's a network simulator with tons of guided labs, covering all of the topics you need to know for the CCNA. Click the link in the video description to check it out. In this lab, we'll configure dynamic NAT as well as PAT. This is the same network topology as in the previous lab, so let's get right into it. In step 1, I'll configure dynamic NAT on R1. First, let me configure the inside and outside interfaces. Enable conft interface G00. This is the external interface connected to the internet, so IP NAT outside. Then interface G01, IP NAT inside. Now, I want to translate all traffic from 172.16.0.0/24. So let me create an ACL that matches that source IP. Exit, access list 1, permit 172.16.0.0, 0.0.0.255. So, anytime PC 1, 2, or 3 sends traffic out to the internet, R1 will translate it. Next, I'll create the address pool. The instructions say to create a pool with just two addresses, 100.0.0.1 and 100.0.0.2. So let's make it. IP NAT pool, and I'll name it pool 1, then 100.0.0.1, 100.0.0.2, then netmask, and I'll just specify /24, 255.255.255.0, because the instructions say from the 100.0.0.0/24 subnet. Finally, I'll configure the NAT statement itself. IP NAT inside source list 1 pool 1. So R1's dynamic NAT configuration is now complete. Next, let's try to ping google.com from the PCs. First, PC 1. Actually, I'll just ping the DNS server 8.8.8.8 first. Ping 8.8.8.8. I just want to make sure all the devices finish the ARP process first. As I've said many times before, it can be a little slow in Packet Tracer. Okay, now let's ping google.com. Ping google.com. Okay, the ping works. Now I'll do the same on PC 2. Ping google.com. It works here too. Finally, PC 3. Ping google.com. No response on PC 3. Why is that? Well, I only configured two public IP addresses in the NAT pool, and they are currently being used by PC 1 and PC 2, so PC 3 can't get a public IP address. Let's check the translations on R1. Do show IP NAT translations. Okay, so there are lots of translations here. Notice that 172.16.0.1 has been mapped to 100.0.0.1, and .2 has been mapped to .2. Now, the output in Packet Tracer is a little different than I demonstrated in the lecture video. We have ICMP entries and UDP entries, but the simple inside local to inside global mappings I showed in the lecture video aren't entered into the table. Just be aware that Packet Tracer doesn't always operate exactly as real Cisco IOS will, and don't worry about it. In the CCNA exam, you might be asked to interpret the output of a NAT table like this, but you won't be asked something like, which entries will be in the NAT table if PC1 pings the server. Okay, so in step 3, we are going to change the configuration to PAT using R1's public IP address, the one on its G00 interface. First, I'll clear the translations. Do clear IP NAT translation, and then an asterisk. Now, the instructions say to remove the current NAT configuration, but let me show you something. Do show run, include NAT. Okay, so we have the command ipnat inside source list 1 pool pool 1. Now without deleting that, I'll enter ipnat inside source list 1 interface G00 overload. And now let's check the running config again. Do show run include NAT. The previous NAT statement has been replaced. So there isn't actually any need to remove the old configuration first. Although the pool still remains, so you can remove that too if you want. Okay, so that's all we need for the PAT configuration. I specified interface G00 overload. So R1 should translate all traffic from 172.16.0.0/24 to the IP address of its G00 interface, 203.0.113.1. Let's try it. I'll ping google.com from each PC again. PC1 first. Ping google.com. Okay, and then PC2. Ping google.com. Next, PC3. Let's see if the ping works this time. Ping google.com. Okay, this time it works. Now let's check the translations on R1 once more. Do show ipnat translations. Notice that all of the inside local addresses, 172.16.0.1, 2, and 3, are translated to the inside global address, 203.0.113.1. R1 uses the protocol and port numbers to keep track of the different communication flows between the PCs, the DNS server, and google.com. Okay, in this lab we configured dynamic NAT using a NAT pool, and then changed it to PAT using R1's interface IP address. That's all for this lab. Next, let's take a look at a bonus lab in Boson Software's NetSim for CCNA. Okay, here's today's Boson NetSim practice lab. The lab is NAT pool. So we are going to practice configuring a dynamic NAT with a NAT pool, as well as some RIP version 2 configuration. So these are the routers, router 1 to router 2, and in this lab we're actually going to translate from private IP address to private IP address. So there aren't actually any public IP addresses in this lab. Now usually you're going to be translating from private to public, but it doesn't have to be that way. Okay, here are the lab tasks, only 7 of them, so we're going to go through the whole lab this time. Okay, let's get started with task 1. Configure router 1 with a hostname, IP addresses, and configure the serial link. Okay, first the hostname router 1, and then the interfaces. That's F00, then the serial interface. Oh, and I have to set the clock right here. It says that this is the DCE end. So 64 kilobits is 64,000 bits. Okay, and then loopback 0. Now loopback 0 is actually mentioned in step 5 of the lab, but I'll configure it now since we're already configuring interfaces. Okay, and then for step 2, we'll do the same on router 2. First the hostname, router 2, F00. Okay, and that's step 2. So we've configured the router interfaces and enabled them. And now we will do the NAT configuration on router 1. Okay, so first, let's configure the ACL 10. So it says we want to configure it so that any host connected to router 1's fast Ethernet 00 interface will be NATed, will be translated. So that network is 192.168.101.0/24. So access list 10 permit 192.168.101.0. There we go. And then the NAT pool should have the pool name good pool, ipnat pool, good pool. it should be a pool of 100 available IP addresses from the subnet 192.168.200.0/24, beginning with 200.2. Now, starting at 200.2, we want 100 IP addresses. So that should be 192.168.200.101. However, I checked the lab solution beforehand, and it specifies here 200.2 to 200.102, which is actually 101 addresses, but I'll configure it as it shows here. Okay, and then the actual NAT statement itself. IP NAT inside source list 10 pool gid pool. All right. Oh, and I have to actually configure the inside and outside interfaces. So F00 will be IP NAT inside. S00 will be IP NAT outside. Okay, and then we will configure RIP version 2. On router 1, make sure you advertise the 200.0 network, but not router 1's fast Ethernet 00 network. Okay, so we won't advertise this network to router 2, but because we will use NAT to translate the source IP addresses, this host will still be able to communicate with host A, because we will advertise the 200.0/24 NAT segment into RIP. So router RIP version 2, network 1.0, that's the serial connection, and then 200.0 is that NAT segment. It's also the network of the loopback 0 interface. Okay, that's all for router 1. Next, router 2, router RIP version 2, network 1.0 and 100.0. Okay, so that's RIP. Step 5, as I said before, is to create the loopback 0 interface on router 1. So that's already complete. And then we'll do the ping from host A to host B and check the NAT translations. So here's host A. Host B is 192.168.100.2. Okay, the ping works. And let's check those translations on router 1. Show IP NAT translations. Okay, so when it created the one-to-one mapping, it made this entry here from 192.168.101.2, that is host A, to 192.168.200.2. That's the first available address in the pool. And then it created a separate entry for the actual ping. You can see the protocol is ICMP. Here's the inside local address, inside global, and both the outside local and outside global addresses are host B's IP address. Okay, so that's all for this lab. Let's see if I did everything correctly. I'll click on Grade Lab. And yes, I completed the lab successfully. Okay, so that's a quick look at Boson Software's NetSim for CCNA. This is a great resource for practice labs, both configuration and troubleshooting labs, and there's over 100 guided labs like this in Boson NetSim. So I highly recommend it. If you want to get Boson NetSim, please follow the link in the video description. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to Anand, Pavel, Abraham, Sergey, Njoku, Victor, Roger, Raj, Kenneth, Seamus, HW, Brandon, Aaron, Marcel, Coney, Donald, Seamode, Gustavo, Anthony, Benjamin, Justin, Prakash, Nasir, Erlison, Marco, Daming, Ed, John, Funny Dart, Velva Jacob, Mark, Yusuf, Boson Software, Devin, Lito, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, March 25th, 2021. If you signed up recently and your name isn't on here, don't worry, you'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.